All right. So today, the the concept today is actually pretty simple. All we're gonna do is we're going to learn how to take the derivative of trig functions. It's pretty easy. Um, where things get complicated is just sort of when they make it when they make the problems more complicated looking, and then you have to do stuff with stuff and stuff. So, what are we going to do today? We're going to find the derivative of trigonometric functions. How are we going to do it? We'll follow the rules for sine and cosine, and then we will determine the rest of them from there. And trigonometry is going to pop up everywhere. So it's important that you know how to take the derivative of a trig function. All right, let's go ahead. First things first, these are the rules for sine and cosine. If I want to take the derivative of sine, I get cosine. If I want to take the derivative of cosine, I get negative sine. If I were to keep going, it sort of flashes back and forth. Sine, cosine, negative cosine, sine, cosine, negative cosine. So my recommendation to you, for if you do nothing else, is memorize these two. The derivative of sine is cosine. The derivative of cosine is negative sine. And if you know those, if if those are sort of stuck in your brain, if everything else leaves and you're stuck doing work and you're not sure how, sine and cosine you'll always be able to break it down into sine and cosine. And we'll talk about what that means as we go through here. So these are like the most important. These are bread and butter. The derivative of sine is cosine. The derivative of cosine is negative sine. From there, we're just going to apply these to all the rest of them. Like, for example, tangent. I want to take the derivative of tangent. Well, in order to take the derivative of tangent, what I'm really doing is taking the derivative of sine over cosine, right? Tangent is just sine divided by cosine. So I'm going to take the derivative of this, and since it's a quotient, since it's the derivative of a fraction, I'm going to use the quotient rule. So we got low is cosine. We got high is sine. What's d low is negative sine. What's d high is cosine. And now we're just going to use the quotient rule. Low d high minus high d low over low squared. Low d high. So cosine x times cosine x, which is really just cosine squared x, minus high d low, sine x, and d low is negative sine x, so that's negative sine squared. With this other negative sign, minus a minus is a plus, over low squared. Well, low is just cosine, so on the bottom is cosine squared, right? Low d high minus high d low over low squared. And when you can leave it like this, I guess, but you can actually simplify this in a really meaningful way. Let me show you what I mean. Let me move this over a little bit. Well, remember, I can take the denominator and distribute it, right? So cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. So you could say the derivative of tangent is 1 plus tangent squared. You could also take it one step further, because 1 plus tangent squared if you remember your Pythagorean identities, is secant squared. So I'm not saying that any of these three are wrong, but I'll tell you which one I think is the easiest to look at. You know what I mean? So like you can so from this point on, if you want to have this fact memorized, the derivative of tangent is secant squared, you can do that. If you're like me, I hate memorizing things. I really do. Memorization is awful to me. So what I just do, I literally do this every time. And I show what it is because I don't remember this. I barely remember what I ate for lunch. I can't. So I take the time and actually write stuff out. But if you want to go ahead and memorize this factoid, the derivative of tangent is secant squared, you are within your right and allowed to. No one's going to force you to prove it every single time. I definitely won't. So now let's do the next one. The derivative of secant squared. So first of all, before we get started, let's rewrite secant in terms of sines and cosines. Remember that secant is 1 over cosine. And I'll do d dx this time because why not? So again, this is a quotient rule problem. Low d high minus high d low over low squared. So we've got here's our high, here's our low, our d high. Well, what's the derivative of any number? That's just a number. That's 0, isn't it? And what's our d low? Well, the derivative of cosine is negative sine. So now let's use our quotient rule. Low d high, well, that's 0, minus high d low, that's minus negative sine, so that's plus sine, over low squared. Now, again, can you leave it like this? Yeah, sure, why not? But like oftentimes you're going to find that you can break this up a little bit and it looks better. So you see that there's sine over, and then there's two cosines, right? Cosine squared. Well, isn't sine over cosine tangent? And 1 over cosine is secant. So you could leave it as this, but oftentimes what they'll show is that the derivative of secant is secant tangent or tangent secant, like this, like what I have here. This is usually, if you're looking at a reference sheet, this is what they'll give you. The derivative of secant is secant tangent or tangent secant. All right. Let's continue. Let's do cosecant. So as you're going through, it's going to be the same idea, right? Cosecant is 1 over sine. And if I'm going to take the derivative, I'm going to do the same thing. Here's my high. Here's my low. Now I've got to do my d high, which once again is 0. I've got to do my d low, which once again, the derivative of sine is cosine. Now we're going to do it. Low d high minus high d low over low squared. Low d high, well, that's 0. because anything times 0 is 0, minus high d low. Well, 1 times cosine is cosine over low squared. And again, you can take a second to simplify this down because they're not going to write it this way. Usually, they're going to write it as let me take the steps here, just like I did last time. They're going to rewrite it as cosecant cotangent. But how did we get there? Well, negative cosecant cotangent, because there's a negative sign here, right? And I'm just breaking up this sine squared like this so you can see it a little bit better. But 1 over sine is cosecant, and the negative follows. And cosecant, cosine over sine is cotangent. And so once again, can you leave it as any of these other ones? Yeah, I guess. But like here, this is the most simplified, we shall say, way that it should look. All right, one more. We got to do cotangent. And cotangent is going to follow exactly like tangent, but upside down, right? Cotangent is cosine over sine. And once again, here's my high. Here's my low. My d high is going to be, well, the derivative of cosine is negative sine. My d low, the derivative of sine is cosine. Then I'm going to use quotient rule. Low d high minus high d low over low squared. So once again, now you've got negative sine squared x minus cosine squared x over low squared sine squared x. So now let's simplify this. I can pull out a negative 1 from the top. And then what do I have? Sine divided by sine is 1. And I pulled it out to the plus. Cosine over sine, we've got cotangent. And 1 plus cotangent, remember, that is cosecant squared. So once again, can you leave it as one of these? Yeah, I guess. But generally speaking, this is the one that they're gonna have as a reference. This is the one they're gonna have as a something for you to look at. And so I want you to look at the commonalities here. Sine and cosine are linked together like this. Tangent and secant, cotangent and cosecant, right? So tangent, the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So the cos are with the cos. Tangent is with secant. Cotangent is with cosecant. And then when you do secant and cosecant, secant, tangent, secant, cosecant, negative cosecant, cotangent. So a couple of things that are like super duper common, right? Number one, anytime you're taking the derivative of a cosecant, a negative pops out, or a any co actually, right? Take the derivative of cotangent, negative pops out. Cosecant, negative pops out. Cosine, negative pops out, right? With sine, secant, and tangent, it stays positive if it was positive to begin with. Tangent and secant are lumped together. Cotangent and cosecant are lumped together. So if you can think about those patterns, it's going to help you. Me personally, I don't memorize it. I just don't. One, because I trust my ability to figure out if I need it, and two, because I hate memorization. Now, I'm not saying that because I know some of you, you're big flashcard people. I've seen some of you like quizzing yourself with flashcards. If you need that because that's the way you learn to start out with, that's totally cool. You can memorize each and every one of these. You know, derivative of sine is cosine. The derivative of cosine is negative sine. These I would memorize, and I have memorized. And these are the only two. But if you need to, derivative of tangent is secant squared. Derivative of secant, secant tangent. The derivative of cosecant, negative cosecant, cotangent. Derivative of cotangent, negative cosecant squared. Here I want to find the derivative for y equals 16x plus 5 cosine x. All right, so when you're doing these problems, take the time, especially if you see plus signs and minus signs in places, split everything up. You're going to do each of these pieces separately from each other. The derivative of 16x, remember, when it's an x here, you can drop the x. The derivative of 16x is just the number 16. Now we're going to do the second part. The derivative of cosine is negative sine. So the derivative of 5 cosine is negative 5 sine, right? And so now we're just going to combine our like terms and be done, right? So our derivative with respect to y, dy dx is 16 plus, and that's a minus, so that takes over, 5 sine x. And that's the end of my problem. Don't think you have to try and do everything all at once. You're not a machine. Do things in pieces so that you can work more easily. Our brains love small pieces. It makes us work so much more efficiently if we can find small pieces to work with. Here, notice what's going on here. I've got x to the 7th times the sine of x. When you see or say the word times, you know you're thinking product rule. Here's my left. Here's my right. Well, what's my d left? What's my d left is we're going to bring down the exponent and drop it down once. We brought down the exponent. We bring it down 1. So that my d left is 7x to the 6th. My d right, well, what's the derivative of sine? That's cosine. And now I'm going to do it. Left d right plus right d left. Left d right plus right d left. And I'm going to write it so that the variable parts, is in front, just because that's how I like to see it personally. Me personally, I hate seeing variable terms after like a cosine because it can be confusing sometimes. So look, once again, we just did the same thing. We realized that we had to use product rule, left d right plus right d left. We found our d left and our d right, and then we just put it all together. Left d right plus right d left. And that's all there is to it. What's next? So once again, look, we have two different pieces that we have to take care of. This piece and this piece. Well, if we look, what's the derivative of a number? Just 0, right? So this part goes away. We are officially done with that 8. But now look, this first part is a product. Fifth root of x times secant, right? So if I'm going to do this, well, I got to use the product rule. Left, right. And what's my d left? Well, it helps to work it out. Fifth root of x, that's really x to the 1/5, right? So let's take the derivative of x to the 1/5. And we look and it's like, okay, bring down the exponent and then drop the exponent down by 1. So we got 1/5 x to the negative 4/5. Right? Well, that's easy. And then d right, we just went over it. The derivative of secant should be secant tangent, but let's double check because again, I don't memorize these. Yeah, derivative of secant is secant tangent. Let's go back here. So the derivative of secant is secant tangent. And now all there is to do is left d right plus right d left. Left d right. And you can rewrite this as x to the 1/5 as well if you like. Some people, when they get to calculus, they stop writing roots because sometimes roots become just a pain in the butt. You have to switch back and forth between them. So if you're that type of person, you would rather just always write x to the 1/5. You can. That's totally fine. They're the same. So left d right plus right d left. And again, I always write the polynomial term, the polynomial piece first, just because I like seeing it out front. If you don't write it out front, make sure that you've got parentheses around your trig function like this, because otherwise somebody might get confused. Like you see here, they don't do it, and that drives me up a wall. And then don't forget this 8 that we took the derivative of is 0, so we don't have to add anything else because plus 0 goes away, right? Okay, more examples. Here again, we have 3 different pieces. Do we have to do them all together? No. Should we do them all together? Definitely not. Let's just do each piece separately. What's the derivative of cosine? The derivative of cosine is negative sine. What's the derivative of negative 2 radical x? Well, again, think about it like this. We've got 2 times x to the 1/2. So we bring down the 1/2 and bring that down by 1. So this is going to be 2 times 1/2 times x to the negative 1/2. That's 1, right? So minus x to the negative 1/2. And then here, we've got this last part now, right? Well, let's rewrite it. 5 times e to the negative x. Remember, when you've got e to something x, you can bring down the number in front. This is a negative 1 in front. The derivative of that is just negative 5 e to the negative x, which is So plus minus, so minus negative 5 e to the negative x. And look, all we did is we did it one piece at a time. We don't have to do it all at once, and we shouldn't do it all at once. Do it in pieces so that it's easy to do. Why would you do one hard thing when you can do 3 easy things, right? Why would you do one difficult thing, try and do it all at the same time and try and juggle it all in your brain when you could just do 3 easy things? Don't make it hard for yourself. Make it easy for yourself. Don't make it hard for yourself. Make it easy for yourself. Here's the next one. We're going to take the derivative of cosecant cotangent. Okay, so let's do that. Now, as you're going through and doing this, again, sometimes it helps to break it up. This is not one of those times. Like, I could do, what would that be? Cosine squared over sine? No, my bad. Cosine over sine squared. I could do the derivative for cosine over sine squared, but why? When we know the derivative for cosecant, we know the derivative for cotangent, right? This is a product rule. Here's our left, here's our right. What's our d left? What's our d right? Well, again, I don't memorize these things, so I'm going to go back. Derivative of cotangent is negative cosecant squared. The derivative of cosecant is negative cosecant cotangent. Too far. So the derivative of cosecant is negative cosecant cotangent. The derivative of cotangent is negative cosecant squared. So now look, left d right plus right d left. Let's do it. Left d right, that's cosecant times negative cosecant squared. So that's negative cosecant cubed, because 1, 2, 3, right? Negative, so we got minus, because it's plus a minus. Cotangent times cosecant, so we got minus cosecant x cotangent squared x. Hey, much easier to do it that way, right? You tried to do that with the you tried to do that with the sines and the cosines, you'd be here all day. But if we have this tool, it's going to make our lives easier, right? Don't make your life difficult. Take it easy. All right. Look at this. We've got tangent x over 1 plus tangent x. So this is quotient rule. We've got our high, we've got our low. We need our d high. We need our d low. All right. Derivative of tangent should be secant squared, right? Again, I don't memorize these things. I'm going to quadruple check. Derivative of tangent is secant squared. Yay, I was right. So and then the derivative of this thing down here, well, first of all, this 1 goes away. Take the derivative of a whole number and it goes away. And then the derivative of tangent, oh, it's secant squared again. So low d high, secant squared plus, and I'm going to distribute the secant into both of these, right? Secant squared tangent, right? Or tangent x secant squared x, right? Low d high minus high d low Oh, this is gonna be nice. I like this. Over low squared. Now, this looks like a mess, but look at this. These two cancel out, right? This minus that, those are the same thing, right? They cancel out. So look at what we're left with. We're left with secant squared x over this thing. 1 plus tangent x quantity squared. Hey, that's cool. It's cool that that came out in the wash like it did. That's cute. Okay, let's do a couple more. So once again, rewrite this. I don't want to deal with this if I don't have to. Bring the cosine out of the denominator. Make this 7 secant x plus 2 cotangent x, right? And then just take the derivative. And remember, take the derivative separately. What's the derivative of secant? Secant tangent, right? What's the derivative of cotangent? Negative cosecant squared, I think. Yeah. Ta-da, you're done. Simple. Simple, 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 simple. Don't make life difficult. Do it the easy way. All right, so once again, do each of these separately. Don't try and do it all at once. Don't let this scare you. Do each piece on its own. Do the easy one first. 8 sine x. Take the derivative. What's the derivative of sine? Cosine. 8 cosine x. Do this one now. We got a product rule. 8x cosine x. Left, right. Yeah? D left is just 8. D right is negative sine. So now we can write this part out. Left, D right. Plus right, D left. And then we got to do the same thing with this one, yeah? Again, make these their own little mini problems, and then you can just smush it together. Here's my left, here's my right. My D left here is 8x. My D right here is cosine x. And then just left D right plus right D left. Left D right for x squared cosine x. Right D left, 8x sine x. And I don't know if you're noticing how a bunch of these are looking to cancel out, but look at what we got. We got this plus this minus this. So let's write out this whole thing. 4x squared cosine x plus 8x sine x minus 8x sine x plus 8 cosine x minus, right, that's a minus sign there, 8 cosine x. And it just so happens it's not always going to work out this well, but look, the calculus gods have smiled upon us, and these cancel out, and these cancel out. Nice, right? So dy dx 4x squared cosine x. Hey, look at how simple that became in the end. Nice. Here's another one. Don't try and do this all at once. There's no reason. Do these all in pieces. Take the derivative here. Bring down the 4. Drop the exponent by 1. So 5 and 4 makes 20 because we're times. T, 4 minus 1 is 3. Well, there's the first one. What's the derivative of secant? And then what's the derivative of 3 times e to the t? Just 3 times e to the t. Remember, the derivative of e to the x is just e to the x. Same thing with any letter. The derivative of e to the whatever, if it's just the letter, then it's just the same thing. So, what is my ds dt? Well, we've got 20t cubed minus, don't forget that minus sign there, minus what? Secant tangent plus, and nothing canceled out in this case, but not that bad because we broke it up, right? Just do little bits here and there. Just do little bits here and there. There's no reason not to, right? Okay, what do we have next? Oh, great. Look, we're going to take the derivative. Well, let's rewrite this first. This is really 6 plus sine q, right? Well, let's take the derivative now. What's the derivative of 6? 0. Nobody cares about you anymore. What's the derivative of sine? Cosine. And voila, we are done. Yay! Easy. Let's do this one now. Okay, so this says find y double prime. So that means in order to do this, we're going to first have to find y prime, and then we're going to have to go again, right? It says find the second derivative, so we got to take the derivative twice. Well, let's do it. What's the derivative of secant? Secant tangent. So this is just 5 secant x tangent x. Now we got to do it again. Y double prime. Well, in order to do that, we got to use the product rule, right? Because it's secant times tangent. So left d right plus right d left. Well, okay, so left is 5 secant. So d left is going to be 5 secant x tangent x. And then right is tangent x. So d right is going to be secant squared x. Well, now we've got it. Let's do it. Left d right, 5 secant x times 5 secant x tangent x. Right? Sorry, let me try that again. Left d right. 5 secant x times secant squared x, right? So we got 5 secant times secant squared is secant cubed plus right d left. Tangent times secant tangent. Well, there's a 5 out there. 5 secant tangent. And then tangent times tangent is tangent squared. And that's it. So we did our first derivative. So if they want the second derivative, like it says here, first we got to find what the first derivative is. Then we can go through, take the second derivative. Right? It's basically just telling you to do the derivative twice. Pretty simple. Remember what I've been saying. They're going to ask this question over and over and over and over and over and over and over. And sometimes it'll be the exact same way. Sometimes it'll be a different way. But here it's the same thing. Find the equation of the tangents. Well, y minus y1 equals m times x minus x1. We've got all our x values. So we're going to have to go through and find our y values and our slopes. So it doesn't matter what order you do this in. It really just depends on you. If you're the type of person you want to have the full point and then you're going to do the slope, great, awesome, cool. If you want to do the slope first, come back, find the point, also great, also awesome, also cool. It's completely dependent on you. But you're basically doing here to get this problem complete 2 separate tasks, right? Find m, find y. 1, right? So we've got our x1. So let's do 1 or 2 of these. At x1 equals pi over 2. Well, what does y equal? Let's look. I plug in cosine, and what do I get? What's cosine at pi over 2? The x value here is 0, right? So if x is pi over 2, y is 0. Now I got to find the slope. That means I got to get the slope equation. What is my derivative? Well, what's the derivative of cosine? Negative sine. And now I want to find what the slope is at pi over 2. Once again, I'm here at pi over 2. This is cosine, but I want sine now. What's sine? Is 1. So sine is 1 at pi over 2. So the derivative here is going to be negative 1. The slope is negative 1. So now I've got x1, y1, and slope. Let's plug it all in. Y minus y1 equals m times x minus x1. And like I said, why do anything but just leave it here? No reason to do any more. And then you're going to do the exact same thing for 3 pi over 2 and 2 pi. I will leave these as an exercise for you to see if you can do it. Obviously, when you're doing your homework, you're going to have all 3 of these to do. Whatever the numbers are, they might not be pi over 2, 3 pi over 2, and 2 pi. They'll probably be other values, maybe pi, 3 pi over 4, 7 pi over 6, whatever. It doesn't matter. It's going to be 3 values, probably between 0 and 2 pi, like they have here. All right, now I have one more. And they're asking for a lot. They're asking for a lot, but the great thing is that it's very easy to do it all. So first of all, let's look at what they ask for. The equation below gives the position s equals f of t. So it's saying that the position s is a function of time. So you can, from now on, you can be talking about s or f of t. They mean the same thing. Of a body, that got dark real quick, of a body moving on a coordinate line, s in meters, t in seconds. So what we want to find is, and I'm so excited they included, so velocity, speed, acceleration, and jerk. So velocity is the derivative of distance. It's the rate at which your distance changes. Speed is just the absolute value of velocity. So if you're going negative, your speed is still positive, right? Think of speed like distance. You can't walk negative 10 feet. Even if you're going backwards, you're still walking 10 feet. Acceleration is the rate of change of your speed. How fast is your speed increasing? Right? How fast is your speed changing? And then jerk. How fast is your acceleration changing? When you're driving a car and you're driving and you're putting your foot down on the gas pedal and it's a smooth acceleration, your jerk is 0. But every one of us has one friend where you feel like you are being put through a roller coaster every time you drive with them. And if you don't, then you probably are that friend. Just saying. But you go through and your friend is like just like slamming on the gas pedal and then you like, ugh, and you get smacked against the side of the door. You're just everywhere. You're holding onto the Jesus bar for dear life. Yeah. Those are the situations when the jerk is non-zero. If you're sitting there getting thrashed around, it's because the acceleration is not constant. The speed is not changing smoothly, and so you're getting jerked around. That's why it's called jerk, by the way, because you're getting jerked around. Sometimes I've seen jerk called snap. You're getting snapped around, right? And then because scientists have nothing else to do with their time, they named the next derivatives after that crackle and pop. Snap, crackle, and pop, because somebody really enjoyed Rice Krispies at some point, I think. But that's actually a true thing. So what's going to help us is if we start out by understanding what the units are. Speed and velocity are both in distance per time. Here it's meters per second, right? Acceleration, distance per time squared. Meters per second squared. And then that would mean that jerk, distance per time cubed. I'm kind of geeked about the fact that they included jerk here. That's great. That's awesome. So what we want to do, before we do anything else, let's find what the first, second, and third derivatives of our distance function actually are before we try and do anything else, because it's going to be a pain in the butt if we try and do like one thing and then we have to come back and do something else. Let's just generate all of them right now. So distance, let's do velocity. We'll take the derivative of distance, and so the 2 goes away. Take the derivative of sine is cosine, so we got -3 cosine of t. Now, we did velocity, and speed's going to come from that too, so we don't have to do it twice. We're going to do acceleration now, which is the derivative of velocity. What's the derivative of cosine? Negative sine, right? So -3. And then finally, jerk, which is the derivative of the acceleration, which is, what's the derivative of sine? It's cosine. So now we have our functions. Distance, which you'll see as s a lot. I don't know why. I never understood that, but that's just the letter that they used. If I was going to use a descriptive variable, I'd use a D, but probably because derivatives have D's in them, we don't like to use D's. But I don't know. Who am I? So now that we've done this, what we can do is we can find the velocity, speed, acceleration, and jerk when we're at pi over 4 seconds. So let's start here. Notice we don't care about where it is, which I don't know. That seems sad, but oh well. So -3 and then cosine of pi over 4, right? Well, what's the cosine of pi over 4? And it just radical 2 over 2, right? So this is -3 radical 2 over 2. And that's our velocity. Notice, and again, we were talking about meters per second, right? -3 radical 2 over 2 meters per second. Speed is just going to be the absolute value of the velocity. So if we are going in a negative, we just make it positive. So the speed, so let's see, velocity at pi over 4, let's write it out, -3 radical 2 over 2 meters per second. Speed, I'll do SP, at pi over 4 equals 3 radical 2 over 2 meters per second. Acceleration at pi over 4 is, well, let's plug it in now, right? Acceleration, we're at sine. Well, wait, hold on. Sine of pi over 4, that's again radical 2 over 2, because they're the same at pi over 4, right? So 3 radical 2 over 2, right? Because radical 2 over 2 is your sine. 3, right? So 3 radical 2 over 2. And now we got to use the right units for acceleration, which is meters per second squared. Distance per time squared. So maybe it's not in meters and seconds sometimes. Maybe it'll be in feet and hours or minutes. So one example of acceleration could be feet per minute squared, or miles per hour squared, or acres per week squared, whatever. It's just distance divided by unit of time squared for acceleration. And then jerk, we're going to find, again, we plug it in, 3 radical 2 over 2 is what we come out with. So our jerk function at pi over 4 is going to be 3 radical 2 over 2 meters per second. Now we've gone the one derivative more, so it's not squared anymore, it's cubed. And there we go.